Now that we've had a chance to look at the basics of logarithms and some solving basic equations, we're going to look at some properties of logarithms and using those to solve exponential equations. So the two properties that we are going to focus on this year are the exponent property and the change of base. The exponent property tells us that if we have an exponent up top attached to the logarithm, we can bring it in front and multiply. And the change of base property tells us the base, we can rewrite this as base 10, and we're going to move the base to the denominator of the fraction. So think base, lower part of the fraction. It'll be log b on the denominator, and then log m on the numerator. So again, we're assuming base 10. I'm just going to do a couple quick examples with those two properties before we get into the solving equations. So for change of base, I have log base 4 of 10. I would rewrite that as log 10 divided by log 4. And then we can actually put that right into the calculator. I'm just going to have to drag this down a little bit so that I can see it better. So our log button would be here. You could do alpha y equals. Put it in fraction form. Log 10 divided by log 4. And we get an approximate answer of 1.661. Something that we're going to do when we solve equations is we're going to give that exact and approximate form, so that will become important. And then the second one, it's really just another repetitive example. We're going to put the base number on the denominator first, and it helps sometimes to write that in first so you don't mess up, flip-flop the order, and then log 8 on top. Again, you can plug that in the calculator. And you can put the 1/3 as a fraction or not, it doesn't matter. And this comes out to be negative. It makes sense actually that it comes out to be negative whenever we have a fraction inside of here. We are going to get a negative answer on that part. And then I'm going to use the exponent property for solving an equation. But we're going to take it and go backwards. So if I had 2 log base 3 of x is equal to 4, the first thing I can do using that exponent property is bring the exponent back up top. So make this log base 3 of x squared is equal to 4. And then we can take that and switch to exponential form, which is something we've already done with solving log equations. So this will be 3 to the 4th is equal to x squared. You get 81 is equal to x squared. If you take the square root, normally you would do plus or minus. But remember we had talked about that inside of the logarithm has to be positive. And you can check this in the calculator. If you to change your base, you could do log 2, log 9 divided by log 3. And see if that comes out to be equal to 4. I'm not going to go over the calculator and do that right now, but it should come out to be that. Okay, I have more examples in the posted notes, but I am going to decrease the amount for this video. So you can check out some more examples on the posted notes if you would like. All right, our steps for solving an exponential equation. So now we're in an exponential equation that we actually can't solve by breaking down. 3 and 7 do not have a base in common. So the way we are going to solve this is we are going to take the log of both sides. When you do that, if there's more than one thing in the exponent, make sure you put parentheses around the exponent. I know we've done that already, but we want to continue doing that. And then we're going to do something else with that after. So first thing I want to do is log 3 to the x minus 1 equals log 7. Make sure you don't make the 3 and the 7 look like bases, because we're using a base 10 for this so that we're able to plug it in the calculator. So again, put parentheses around the exponent, and we are then going to take that exponent and use the exponent rule. So we're going to bring that x minus 1 in front of the log 3. And you'll notice in this case the variable is only on one side. So when we go to solve for x, it might be worth dividing out the log 3 first. So I can divide by log 3 on both sides. So now I'm just left with x minus 1 equals log 7 divided by log 3. And add 1. Don't plug in anything into the calculator yet because I want you to give me an exact and approximate answer. So this would be my exact answer. And then if I want my approximate answer, I go to my calculator. Again, I recommend for these using the fraction tool if you have it, because we'll just eliminate any issues with mistakes in typing things in or not closing parentheses where you should be. So I end up getting an approximate 2.771. I'm going to label this exact and approximate. When you do these, just make sure you have both answers in question. Okay, third example, 2 to the 2x is equal to 6. We're going to use the same technique. I did outline a different technique in the posted notes, but we're going to go with this technique and just stay consistent with it. So first thing, take the log of both sides. Take your exponent then, bring it in front. Now in solving this one for x, since I have everything, like I have 2 times x times log 2, you want to actually just divide everything out that's surrounding the x. So we're going to divide out the 2 and the log 2 at the same time. So we don't end up getting a fraction within a fraction. And this final exact answer is one that a lot of times people mess up typing in the calculator if you don't use the fraction tool. So that's why I highly recommend that option. If you didn't use the fraction tool, you'd have to make sure you put in a few extra parentheses. So we get an approximate answer of 1.292. And the rest of them will be kind of the same process. We're just adding in some other elements as we go through each one. So take the log of both sides. Bring the exponent in front. And just like the first example, when I'm solving this for x, I'm going to get rid of the log 5 first. I could distribute it. That would give me a slightly different looking exact answer, but I would end up with the same approximate answer, so it doesn't really matter. The only catch with this one is we have a number in front of x that we have to divide by, and dividing when you already have a fraction kind of gets messy. So we want to talk about a different option instead of dividing that you can do with this. So you can divide both sides by 3, or multiplying by 1/3 gives you the same result. I would multiply by 1/3 on both sides and then distribute that in, because it's much easier to do that if there's already a fraction there. So this will still cancel on the left, but 1 times log 2 is log 2 on the top, and then 3 times log 5 on the bottom is 3 log 5, plus 1 times 1/3 would be 1/3. So that would be how you could give your exact answer, and then you would type it in the calculator. Again, using the fraction tool for probably both of them. I'm not going to go back and type this one in. You get a shot to try that on your own and make sure it comes out okay. And then we're going to do one more example. That's an E example. Am I on number 5? Sorry for scrolling back and forth. And there's another E example posted. I'm just going to do one of them because they're kind of the same thing. Now, another option is you can take, instead of E, instead of log, you can take the ln of both sides for E. Really, you could do this with any of the questions, but you definitely want to do this for E. And the reason why is that ln of E, or ln of something, is the same as log base E of that number. So it ends up coming out a little bit nicer, and then also the fact that ln of E is equal to 1, if you were to type that in your calculator, is a nice result. Second division sign would be the E I would choose if I wanted to type in ln E. So you can see that does come out to be 1, which means taking the ln of both sides is a little bit better than the logarithm. So we're going to do ln E to the x minus 4 equals ln of 3. There are a few steps you could probably skip on here, but I'm going to write all of them out in the example. And like I had stated before off to the side, this is an important aspect here, the fact that ln of E is equal to 1. So really we're just getting 1 times x minus 4, which leaves us with x minus 4. It's a lot less complicated to solve the E examples if we do change it over to an ln. So now our exact answer is ln of 3, plus 4. Oh, let me erase that. For our exact. And then for the approximate, when you go to type it in, now we're selecting the ln button, which is right below logarithm. So you just want to get familiar with those buttons on the side there. And we get an approximate answer of 5.099. This gives you a good overview of the different types of equations you might see and the technique that we're going to use this year for solving.